Temperature can also affect an equilibrium. So when you have a reaction and you're looking at a forward rate or a reverse rate, the temperature can increase that rate because of increasing the number of collisions and the energy of those collisions. But that's not what we're talking about here. We're saying we have an equilibrium. What's going to happen if we change the temperature on it? Well, this is going to apply to exothermic reactions and endothermic reactions. In an exothermic reaction, we can think of heat as being a product. An exothermic reaction gives off heat. It produces heat. So if we increase the temperature of an exothermic reaction, that's like adding heat to the product side, and the reaction will shift away from that. In an endothermic reaction, we can think of heat as a reactant. Endothermic, heat going in. It's a reactant. If you increase the temperature, you're increasing that reactant of heat, and that's going to cause the reaction to shift to the product side. So this reaction is exothermic, reacting nitrogen and hydrogen, forming ammonia. It's exothermic, it releases heat. If I add heat, I can think of this as a product, right? If I'm increasing the concentration of this, it's going to shift away from that. Increasing the temperature will cause the reaction to move over here. If I remove heat, if I lower the temperature, it's going to cause the reaction to shift this way. This is a relatively easy way to control a reaction. You can do it just by changing the temperature that is happening. In an endothermic reaction, heat is a reactant. So I add heat, the reaction shifts to the right. I remove heat, the reaction shifts to replace that by shifting to the left. This is a really neat reaction because we've got two gases here. N2O4 is colorless and NO2 is brown. And so you can actually see what's happening. So here is a tube containing those gases at equilibrium. Here we have it in a warm container, and we see that the gas is brown. Heat is a reactant because this is an endothermic reaction. When we go to a warm temperature, we're adding heat. It pushes the reaction towards the right, and we see the brown gas. We take that same sealed tube and stick it in a cold container. We're removing heat. The equilibrium says, hey, I wanted that, and it shifts to remake the heat. And the color changes. It goes colorless. You go back and forth all day long. Make it brown, make it clear. Make it brown, make it clear. Eventually you get tired of it and go do something else.
Could that act kind of like a thermometer?
It could act like a thermometer. Yeah, definitely could. So in an exothermic reaction, heat's a product. Endothermic, heat's a reactant. So you can answer these questions by saying, well, I'm increasing the reactant, I'm decreasing the reactant. How is that going to shift? So here we have a reaction. We're not given a delta H or anything, but we're told the reaction is exothermic. Exothermic, does that mean heat is a reactant or a product? It's a product. So plus heat. It's not neat, it's heat. Write that in. Then answer the question, what's the effect of increasing the temperature? Increasing the temperature is adding heat. It'll go to the left. What if I decrease the temperature? It'll go to the right. So we're dealing with equilibrium and Le Chatelier's principle on a very basic level. There, you can do a lot more complicated things with this, but we're just looking, which direction is it going to move in?
Will we need to memorize the definition of principle or not?
No, I'm not into making you, spit out definitions, but you do need to know the concept. I don't even care if you remember that it's Le Chatelier's principle. That would be helpful, especially if you're going to take more science classes. But just the idea that the equilibrium will shift away. Well, it'll shift to undo the changes imposed on it.